and now that we have practiced our writing of linear functions and using them to solve for unknowns, and hopefully yesterday's practice went a long way to making that easier, you now have the ability to start comparing them. And this is real world stuff. This is an actual skill that I hope that you all want or need. Basically, we're talking about comparing two different things, trying to figure out which is better for you. Say your car breaks down. You need to take it to a garage. It's just something you can't fix yourself. But garages charge a different amount of money for the part, and garages charge a different amount of money per hour. And you need to figure out what was going to be the better deal. You know, you don't trust them to give you a good quote, let's say. Let's say that you have enough knowledge. You go, that job should only take 3 hours. They're trying to charge me for 5. I'm not stupid. You should be able to figure out what's the better deal. Or maybe cell phone bills or clothing. I mean, there are a ton of times in your life where you're forced to compare two different models. Now, are they normally linear models? No, probably not. They're actually probably more than likely going to be exponential, kind of like right here, it's talking about credit card debt. Okay, credit cards are not linear, as you see in this picture. Credit cards are exponential. But we break it down with linear style stuff in the beginning, and towards the latter part of the year, we can compare exponentials and things like that, and I can really teach you how to do some real-world mathematics. So we bring it down to the linear level first, so we can get used to the idea of comparing different models. We want to know, and I spared us the long credit card story. You see, I got rid of all the word problem stuff for this one. They go, look, I'll tell you the story. 2 different people are paying off their credit card loans. Person 1, their loan is being paid off by the picture that you see here. It's a nice graph. It has 2 obvious coordinates on it. One of those 2 obvious coordinates is a really special one. It's a y-intercept. Person 2 is paying off their credit card according to this table. Now, person 2, we can't see the line, we can't see the y-intercept, but we can see a whole bunch of x comma y's. The question is, who's going to pay off their credit card first? That means which one of them will have 0 debt in the smaller amount of days. So my x's are going by days here. So even though it didn't say it, these are days. And this is debt. And that's why the number is going down, because as you pay things off, you should have less and less debt. In order to figure out who's going to pay this thing off first, what we need to do is write an equation for both of them, figure out how long it takes each one of them to pay it off, and whoever has the smaller number of days for payoff, that is the person who pays it off first. Now, is it a 50-50 shot? Yes. Will the test questions be 50-50 shots? No, and here's why. Because right now the question says who pays off their credit card first. The question for the test would say, how much faster do they pay it off? And it would be a number of days. So you'd be forced to figure out how long it takes both of them to pay off and see which one was the faster payoff and figure out how much faster it was by subtracting. And that's how that test question would work. So let's figure out the equation for person 1. I see the coordinate here is 150, 800. And I see up here, oh, what a gift, 0, 1800. And I call it a gift because that is our y-intercept. That will be the b value for person 1. But we do need to find the equation, and I'm going to ask you to use the slope formula, not count your tick marks, because the scales aren't the same. My x's are going by 50s, my y's are going by 200s. It's dangerous to try to count this rise over run. So instead, you use your slope formula. M equals y2 minus y1 over x2 minus x1. You can call this one x1, y1. this one x2, y2, and it doesn't matter which one you choose to be x1, y1. I just typically say the left one is the first one. My slope is going to be found then by doing 800 divided by 1800, excuse me, minus 1800, my apologies, divided by 150 minus 0. That gives me negative 1,000 over 150. Now, the way that we were doing this before, when I was making you analyze your slope, was I was telling you to actually divide them and get you a decimal. So do that here too. So I grab handy dandy calculator. 1,000 divided by 150 gives me negative 6.6 repeating. Oh no, a repeating fraction or repeating decimal, that's no fun. So because my calculator gave me repeating decimal, I'm just going to reduce the fraction because I don't want to have to write this decimal the way it sits. I don't want to have to round it. If it was a perfect decimal and it stopped, then I would ask you to write it out as a decimal. But because it doesn't stop, I want you to just reduce the fraction. And let's see, I can divide both these numbers by 50, and it'll give me negative 200 over 3. No, negative 20 over 3. I'm sorry. Yeah, negative 20 over 3. I divided the top and bottom by 50. That's as pretty as that slope is going to get. But like I said, you can see the y-intercept in this one, so that makes life really, really good. We automatically know just by looking at the picture that b is 1800. So this first one, this first equation is y equals negative 20 over 3 plus 1800. Yikes, right? All right. We have person 1. This is person 1. This is their debt. Now we need a line equation for person 2's debt. And we're going to have to basically do the exact same process. We have to find slope. And unfortunately, we have to solve for y-intercept. Unfortunately. So x1, y1, x2, y2. Notice how I always write the equation? This is why I don't mess up my negative signs. I always write the equation and then I substitute. So 1600 minus 1700 divided by 40 minus 20. That gives me negative 100 over 20, which is negative 5. Other test questions I could ask you. Who is paying off their debt at a faster rate? How much faster? I could ask you questions like that. You see, person number 1, their slope was negative 6.6 repeating. The interpretation of that is, and since my x's are going by days, I see people stretching to see. The interpretation of that is person 1 pays off about $6.67 per day. Person 2 pays off about $5 per day. Now, do you pay your bill daily? No. But if you could, that's what's happening. So which one is paying off their debt at a faster rate? Person 1 is. Their slope is steeper. They're paying off $6.67 per day. But just because they have a faster payoff rate doesn't mean they pay off first. The reason why it doesn't mean that? Because you don't know how much debt person 2 started with, which is their b value. You have to solve for the b value. So I'm just going to split the board because I want to make sure that we don't accidentally mix our math up. We have to solve for our b value. What we know is that y equals negative 5x plus b so far. And our table is full of x comma y's. And just like we did yesterday and the day before, we're going to plug one of those x comma y's in. It's going to help us solve for b. I'm going to use 20 and 1700. The y value was 1700 when the x value was 20. To wait for the active panel to catch up with me. There we go. 1,700 equals negative 100 plus B, and you add 100 to both sides. That gives you that person two's starting debt was also 1,800. These two people had the same starting debt, $1,800. Well, because you've already established which one is paying off at a faster rate, and you can see that they started with the same amount of debt, clearly the person with the faster payoff rate will be the one who pays their credit card off first. That's a lot of common sense to go through, right? Let's say you don't do common sense. You don't like to common sense your way to math. And I go, that's fine. You know what? I kind of respect that because I have very little common sense. So let's just say we do the student thing where you have no idea what's happening. So you write your two equations. And you want to talk about who pays off first. What if the question says how much faster? What would you have done is the question. You go, okay, fine. Wouldn't it be great to know how long it takes to pay off this credit card? Let me ask you a question. If your credit card is paid off, what does your debt equal? 0. So if I want to know how long it takes to pay off, I have to use a debt of 0. And debt is y values. So this is to pay off. To pay off, you would use a 0 for your debt. And you would solve for x, which is the number of days. Still trying to keep my math separate. I'm going to add this 5x to both sides because I don't like to play with negatives if I don't have to. Gives me 5x equals 1,800. And I will grab my handy-dandy calculator and divide both sides by 5. And I believe the answer is what, 90? Or 360? I was off by a factor of 4. 360. 360 days. That's how long person 2 is going to take to pay off. Hey, look, check it out. Person 1, you had a graph. You can't see exactly how many days it took them to pay it off, but you can see 0 debt happens between 250 and 300 days. So even then, see, that's less common sense, more mathematics, proves to you that, yeah, person 1's going to pay it off faster because they took way less than 360 days to pay off. If you wanted to know exactly how much faster, you would have to do the exact same thing I just did for person 2. You would have to plug in 0 debt for person 1, solve for x, and then subtract. Now, I don't know where that number is, but it looks like it's not 275. It's probably somewhere around 260 or 265. So it's about 100 days-ish. Okay. A lot just happened, but none of it was new. It was just doing the skills that I've set you up for the last 2 days more than once. And then just comparing them. Who was faster? What was the faster rate? Who was going to have 0 debt first? How much debt did they both start with? Questions like that. What do you think? Would you like to ask me anything about it? You guys just kind of let me do my thing here, but that's not always the best situation. Okay, well, then I'm going to clear them and move on then. This was blank because for you it was the bottom of the paper, so you had room to take notes on. Okay. So then we go to the one on the back. And it should just be the only one on the back. Short notes. A construction company has to drain 2 reservoirs before they can begin construction. The graph models the rate at which reservoir 1 is drained. And g of x represents the rate at which reservoir 2 is drained. Well, it's not labeled, so I'll go ahead and label it. Reservoir, French word, 2. Reservoir 2. How many hours will it take for the reservoirs to have the same amount of water remaining? Well, I can't really answer that question right now because I only have one equation. I need 2 equations. Once again, I was kind, and check this out. The gift of y-intercept. You don't have to work for it. It's clearly 120. And by the way, my y's are in gallons, thousands of gallons, so to be exact. My x's are hours, but it already said that, I believe. This coordinate is 80 hours, comma, 60,000 gallons. So for reservoir 1, we will need to find our slope. And luckily, y-intercept was handed to us, so we don't have to work for it. y2 minus y1 over x2 minus x1. Call this one x1, y1, because it's the one that's closest to me. And call this one x2, y2. And you can see the line. We expect a negative slope, I would like you to be able to look at graphs and interpret some things. You should be able to look at this graph and tell me how long reservoir 1 is going to take to drain. Just by looking, you should be able to see that number. How long is it going to take to drain? How long until it's completely empty? 160 hours, right there. There is reservoir 1 is empty. Okay. So you can see those kinds of things. All right, let's see. Let's put some numbers in. 60 minus 120 over, it is a 0, not a 6. Let's just write it better. Over 80 minus 0. That is negative 60 over 80. And you can either leave this as a fraction and reduce it down to negative 3/4, or you could use a decimal, since this one's a decimal, and actually divide, and you will get negative 0.75. And you already know your y-intercept. It was given to you on the graph as 120. 1,000, but 120. So reservoir 1's equation, wow, that's like the world's worst one. I could do a little bit better. There we go. Y equals negative 0.75x plus the y-intercept that we could see on the graph of 120. We now have 2 equations. Lots of things I could ask you here. For a test, I could say, which reservoir is draining at a faster rate? So if you were going to answer that question, which of these 2 is draining at a faster rate? Ooh, can I capture them both? Barely. But my people in the back won't be able to see the bottom. Which one drains at a faster rate? Reservoir 1 or reservoir 2? Reservoir 2. Negative 1.2 means it is draining 1.2 thousand gallons per hour. That's 1,200 gallons per hour. Reservoir 1 is draining at 0.75 thousand gallons per hour, which is 750 gallons per hour. So yeah, reservoir 2 is draining faster. Which reservoir started with more water in it? Reservoir 1 or reservoir 2? 2. 2 started with 180,000 gallons. Reservoir 1 has 120,000 gallons. So this time they don't have the same starting amount. Reservoir 2 started with more, with exactly 60,000 more, but it is draining faster as well. I could ask you which one will be completely empty first. I could ask you how much faster will the first one be empty than the second one? How much faster? Well, for this one, you can see, and you've already told me, it's going to take 160 hours before it's empty. You don't have to work for that. You can see it. For reservoir 2, you would have to plug in y equals 0 and solve for x. I can go ahead and tell you. Let's see. Grab a handy-dandy calculator. I could tell you that reservoir 2 would take 150 hours to drain. which means it would actually be empty first. So even though it started with more water in it, its rate is so much faster that it ends up draining first. How much faster? If it takes 150 hours, it's 10 hours faster. I'm hoping that you guys are seeing what I'm getting at here. I'm telling you all the different ways I can make this question a test question. Because writing new word problems is difficult work. So rather than coming up with a whole new story and graphs and tables of data and that kind of bullcrap, for the test, what you do is, as a teacher, you take one of the word problems the students have already done and you just change what it's asking for. I could make this a test question like that without changing anything except for the words. I don't have to change any of the numbers. I could say, which one drains faster? How long does it take the faster one to drain? How much faster did it drain? Meaning number of days. Which one is draining at a faster rate? How much faster is the faster rate? Or the question is actually asked, how long until they have the same amount of water? That's what this question was asking. Now let me ask you, what do you think we would do if I said they have the same amount of water? How do you think we could figure that out? Ideas. What does same mean to you? Lewis, it's okay. Take a stab. It's okay if you're wrong. It's all right. Ask my wife. She says I'm wrong all the time. What do you think? For them to be the same. Well, water is the y values. You would plug in a number for y for both of them and hope that you get the same x, right? But that's going to take a lot of guessing and checking, wouldn't it? Now, could you get there doing that eventually? Of course you could. But to be honest with you, anywhere between 0 and 140, or 120, excuse me, there's 120 options. And what if it's a decimal? Could you get there with educated guesses and start to narrow it down until they got closer, closer, closer? You sure could. But that wouldn't be the most efficient method. It'll work, but I don't think it's the most efficient. Let me ask you a slightly different question. Can someone give me a math word for the word same? Equal. I asked you when their water was equal. Now, Lewis asked me the perfect question. Which one was how much water? It was the y's. So I just asked you, when are their y's equal? That's what this question's asking. It wants to know, when is y equal to y? This is what the question's asking. Well, for reservoir 1, don't we know what y equals? And for reservoir 2, don't we know what y equals? For reservoir 1, y equals negative 0.75x plus 120. For reservoir 2, y equals negative 1.2x plus 180. You see, when it asks how long until they're the same, equal means same. You just set the two equations equal to each other because, like Lewis asked, the y's are the water, and the y's are modeled by the two equations you found. So you set the equations equal to each other because that's the same as setting the y's equal to each other, and you just solve for x. Again, I don't want to have to play with negatives if I don't have to, so I'm going to add 1.2x to both sides. Let's see what we get. 0.45x plus 120 equals 180. And then obviously, we're just solving for x at this point, so we're going to subtract 120 from both sides. Get 0.45x equals 60, and then you divide by 0.45. Going to get some number that's just a little bit bigger than 120. I don't know how much bigger. I'm going to grab my calculator. A repeating decimal? That's okay. 60 divided by 0.45. 133.3 repeating hours. It's okay if it repeats. Because actually, you know 0.3 repeating means a third, right? How long is a third of an hour? That's a half of an hour. It's a third of an hour. 20 minutes. So it would take 1 hour, it would take 133 hours and 20 minutes if I wanted to be exact, because a third of an hour is 20 minutes. 133 hours and 20 minutes. That is how long until they're exactly the same amount of water. I could make it a better test question by saying how much water will be in the reservoirs when they have the same amount of water. It's the exact same question for the teacher. I just changed the words for you. See how easy that is for me to do. I just changed what the question's asking for. So if I say, how much water will there be when they're equal? What do you think you would do? Lewis? Yeah, you'd plug in 133.3 repeating into either one of them. And you don't have to do both because you know they're equal. So you just plug it into one of them. And the answer probably won't be pretty because the repeating decimal. But the point is, that's how you would do it. Again, I'm just telling you all the ways that I could create test questions with very little work for me. I don't have to write a new story. I don't have to change the graphs. I don't have to change the grids. I just change the words. Very, very simple.